Change the camera, so I'm hoping this will work out fine. Which of these word problems represents 8 being divided by a half? So in other words, think of 8 items being divided into halves. How many halves can fit into 18? I'm sorry, into 8. So that's what you're thinking of, the 8 being divided. So let's look at the first situation, because you have to read them. Fran has half a pound of raisins. She wants to share them. In this case, the raisins are being divided by 8 friends, so that doesn't work. John's recipe calls for half a cup of nuts per batch. If she makes 8 batches, how many nuts does he use? So each cup is times 8 because it's 8 batches. No. Kyle has 8 bags of carrots. He gives half of them to Serena. How many bags of carrots does he give Serena? So he's just giving half of the 8. So just breaking in half is just 4. Hamisha has 8 liters of soup. If each serving is half a liter, how many servings does he make? That makes sense. So he has 8 liters, and he keeps on giving a half a liter, and another half a liter, and another half a liter to see how many he makes. So D makes the most sense here. Let's go to the next one. And it is a graphing problem, so I have a lot of information here about the graph. So I'm going to have to start by making this pattern up, and I notice that on this side, 0, 3, 6, 9, 12, because it's increasing by 3. So I can see that. And I can plot those other points. So 6, 9. So I'm going to walk 6 and go up to 9. And I'm going to walk to 8. And I'm going to go up to 12. And to just continue my pattern. Okay. So if she continues to walk at the same pace, which point represents how far she will walk in 8 minutes? So I already did that when I did my chart. In 8 minutes, she'll walk 12 blocks. And I can see that point. In 8 minutes, 12 blocks. So this is 8, 12. Because you have to walk 8, then up 12. Here it is. So you know, walk 8 and then go up 12. Which point represents how far she walks in 1 minute? So I'm going to look at my chart, and I'm going to look for if I made a straight line with my ruler. And if I continue that line, because I noticed to 0, how far is she going in 1 minute? So it's halfway. I know in 2 minutes she goes 3, and it's halfway between the 1 and the 2. So it's 1.5. So 1 and 1.5. So 1 minute. So the time is 1, and here's 1.5. They tried to make it look funny, so you just have to keep on saying it. Sometimes it helps if you write the number next to it, 1, and then 1.5. But you know they could also be 1 and 1.5. So you have to get really used to seeing numbers both ways. But it's right there. All right, next one. There's half a gallon of cider left in the container. Each friend wants to share equally. How much cider will each friend receive? And we want to know how can he check. So what's the opposite of division is multiplication. So if I take this, his answer, and multiply it by 5, I should get 1/4. So I'm going to do the opposite. I'm going to go backwards. So I have 1/20 times 5, and here it is. 1/20 times 5 equals a 4. Makes most sense. Okay, which is the area of the rectangle? So I know area is just base times height. Well, length times width, either way. And I get 21. I have 2 numbers behind decimals. 1, 2. So I need that in my answer. 1, 2. I need 2 numbers behind decimals. So which one is 2100ths? Don't get tricked out by that 0. If it really bothers you, just put a 0 in the 1's place. 2100 square meters. Almost done. Okay, which multiplying, without multiplying, which expression has the smallest product? So I want to know which is the smallest one, even without actually doing multiplying. If it really bothers you, you can just do the multiplying out. But I know that just by looking at it, I'm going to get 1/4, 1/16, 1/36, 1/64. This is the tiniest one. That's a very tiny piece. One piece out of 64. Okay, I'm going to need... what is the value of 700 divided by 7/10? So here's 700 in the house. We talked about this before for a second. 7/10. I can't divide unless this is a whole number. So we're going to use our magnitude of 10. So I'm going to have to move this over once. I'm going to have to times this by 10, which means I also have to times this by 10 to make it even. That's pretty easy. I know a 7 goes into 7,000 1,000 times. If you want to check it, let's check it. 1,000 times 7/10. I know I get 7,000. I have one number behind the decimal. So my original answer was 700. That was what my problem says, 700. Boom, here's 1,000. Okay, let's go to the next one. Another complicated word problem. There's a lot of reading here. Ian is finding the volume of a prism that is 40 centimeters long, 20 centimeters wide, 10 centimeters high. Here he uses the formula length times width times height. He follows these steps to solve the problem. First, he multiplies the 40 and the 20, and then he multiplies by 10. Identify another way he can find the volume. So let's look at our choices here. She could do 40 times 10 and then multiply by 2. So he's just doing the 40 times 10, but it's supposed to be 20. That doesn't make sense. He could do the 20 times the 10, but he still has to do the 40. Yep, then multiply the product by 40. So that makes sense, but let's double check the other ones. He multiplies 4 times 2 times 1 and then multiplies by 10. Let's see if that would actually work, because 4 times 2 times 1 is only going to give me 8 and altogether 80. Just by looking at my numbers, 40 times 20 is already bigger than 80, so there's no way that works. Sometimes you got to double check your math. And in this case, he wants to multiply 40 times 20 and then multiply 40 times 10. That doesn't work. You have to multiply all three numbers together. So no, B is the best answer. Okay. Another wordy problem. Don't get frustrated by these types of problems. Pedro wants to find an equivalent fraction for 3/4. So he recommends that he multiply both the numerator and denominator by 2. So Pedro does not understand why the fraction created in this process will be equivalent. What explanation can Suri give? So this is actually property of 1. And we talked about this, where I can take any number, and as long as I'm multiplying it by a fraction that's equal to 1, I'm going to get an equivalent fraction. That's all she wants to show him, that you can get an equivalent fraction as long as you're using property of 1. So let's see. Multiplying by 2/2 is the same as multiplying by 1. So the fraction of the value doesn't change. That makes sense because we're just multiplying it by 1. That's pretty much what I just explained. As long as you're multiplying it by 1, it's going to be equal. Let's see the other choices. Multiplying by 2/2 is the same as multiplying by 2. This is not true. So I'm going to just X that out because this is 2/2 is not equal to 2. Multiplying by 2/2 is the same as dividing by 2. That is not true as well. Multiplying by 2/2 finds the inverse of each number. No, because we're not flipping the number around when I say the inverse. So even though this is wordy, if you take it one at a time, you'll be able to figure it out. Don't get scared because a word is in there that you think sounds smart. So yes, they're using the word inverse. That doesn't mean that that's what's happening here, because we've seen inverses when we do division. Like if I wanted to just get a reciprocal, I would just flip these over. But inverse just means opposite. Really, this doesn't make any sense here. So don't get tricked. Just take it one at a time and think about what you know. All right, last one. Look at the patterns. What rule shows how you can use a number from the first pattern to create the second one? So let's look at the first pattern. What happens to the second? 5, 10, 10, 20, 15, 30, 20. So you can look at the pattern here, and I notice that each time it's like I'm multiplying it by 2. Each time to get this number, times 2, times 2, times 2. So I take the first number and I multiply it by 2. Boom, here it is. I took the first number and I multiplied it by 2. And that's basically it. So even though these problems look very wordy, just take them one at a time. It just takes patience and real brain power and focus just to think about what they're asking you really to do, and not get tricked by vocabulary or by something looking very wordy.